Okay, so in this video, what I'm going to do is we're going to work through three different examples of problems that you might see using molarity. Um, so let's go ahead and look at our first one. What we will see is that as we work through each problem, kind of the difficulty level gets just a little bit more um, complicated for each one. So let's go ahead and look at this one. So we have a solution is made by adding 0.65 moles of iron 2 nitrate to a 150 milliliter volumetric flask. We want to know what the concentration of this solution is. So I'm just identifying some key parts. When you are thinking about concentration, what you want to think about is when the problem is asking for concentration, you want to be identifying they're talking about molarity. And so the minute you think, okay, we have concentration, we're trying to find molarity, what you then want to identify is you want to remember your equation. Molarity equals moles of solute over liters of solution. Okay, so if we look at what we have our moles of solute and it's already in moles. So we know that we have 0.065 moles. So I'm going to put that on top. 0.065 moles of solute. And we have 500 milliliters volumetric flask, which is going to be our liters of solution, but 500 milliliters, what you want to remember for milliliters is that 1,000 milliliters are in 1 liter. So this is really 0.500 liters. So that's what we need to put on the bottom. You need to make sure that everything that you put into the equation has the correct units. So now what we can do is we can go ahead and divide. So we have 0.065 divided by 0.5. And what we get for our molarity, I'm going to go ahead and write it right down here at the very bottom. What we get is we get our molarity equals 0.13. You could either put a capital M for molarity or you could put moles over liters. And you also want to make sure you identify what type of solution. So iron 2 nitrate. So I'm going to put the iron 2 nitrate at the end. So it's important that you put that so we know what the solution is that we're talking about. So that is your answer for the first one. It was pretty straightforward. We were already given moles. The only thing we had to do was make sure that we had the volume of our solution in the correct units. So let's go ahead and kind of add one more layer of complication. So here we have a solution is made by adding 25 grams of sodium chloride to 250 milliliter volumetric flask. What is the concentration of this solution? So here we have 25.5 grams. We have 450 milliliters. And again, we are asking for the concentration of the solution, which again is molarity. Looking back at my equation, it is moles of solute over liters of solution. Well, in this problem, we're not given moles of solute. Our solute's what's dissolved, which is the sodium chloride. We're given grams. So the first step we need to do is we're going to convert 25.5 grams of NaCl. We're going to convert that into moles so we could plug it into our chemical formula. So in order to do that, we need to find the molar mass of NaCl. So using our periodic table that, again, this is the one that you guys have access to. It's also the same one that is on ptable.com. Our molar mass, so sodium is 22.99. It's right there. Chlorine, there's just one chlorine, and this is going to be 35.45. So I get 58.44 grams per mole. So if I were to set this up, I'm going to have 25.5 grams of NaCl. And now here's my molar mass, 58.44 grams over 1 mole. And again, this is NaCl. So this is going to give me my moles. And again, to convert between grams and moles, I use my molar mass of that compound. So 25.5 divided by 58.44. I get 0.43. I'm going to keep one more digit. We'll say 6, and this is moles of NaCl. Now that I have my moles, I could start plugging this into the equation. I know my volume. I just need to make sure that I convert that into liters. So we're going to take our 250 milliliters, and that ends up being 0.250 liters. And now I can plug this into the equation. So molarity equals 0.436 moles of sodium chloride over 0.250 liters of solution. 0.436 divided by 0.25, and my molarity equals, excuse me, not a 0, 1.744. I'm going to put molar NaCl. Don't forget, you could also put moles over liters. Either one is totally fine. So for this one, before we plugged it into our final equation, we did need to make sure that we converted our grams into moles. And again, we do that using our molar mass that we calculate using the information in the masses from the periodic table. Okay, let's look at one more type of problem. This is similar to the problem that we did for our demo on how to make a concentrated solution. So next, what we want to answer is, how do you make a 350 milliliters of a 0.25 solution, molar solution of KCl? So again, when it's asked, how do you make, the thing that we need to calculate is we need to calculate the mass of KCl needed. That's the first thing that we need to calculate. And then we'll write how to make that solution. So if I want to figure out the mass, you want to, again, remember that we can take this molarity, we could take this value right here, we can kind of break it up. We could say 0.125 moles of KCl over 1 liter of solution. Now, we don't want 1 liter, we want 350 milliliters. So what I can do is I'm going to rewrite this. I'm going to use this as a conversion factor. And 350 is 0.350 liters, 0.125 moles of KCl over 1 liter of solution. And so I get 0.350 times 0.125. I get 0.04375 moles of KCl. Now I need to convert my moles into a mass because, again, I want to be able to weigh this out on an electronic balance. So I need to convert this into grams. I need to convert this into the mass. So I'm going to use my molar mass of KCl. So let's calculate our molar mass. So we have potassium right here, which is 39.098, plus, that was KCl, so we have 35.45 for chlorine right off to the side. So I get my molar mass. So let's go ahead and set up our problem. So I'm going to start with my moles, 0.04375 moles of KCl. And my molar mass is 74.548 grams over 1 mole. And again, this is KCl. And what I get is my mass to be 3.26 grams of KCl. So that's how much I need to add. So if I were to write out my steps, which the question says, how do you make? So if you make it, the question is asking, how do you make? you need to add more than just the mass of that. So if I were to write out my steps, I would say I would, 1, weigh out 3.26 grams of KCl. Next, I want to add all KCl to a 350 milliliter volumetric flask. Then what I want to do is I want to add, remember we add about half, maybe it could be a little more. So we're going to add approximately 200 milliliters of water and dissolve all the KCl. Okay? Then the next thing I'm going to do, once I've dissolved all the KCl in my volumetric flask, I'm going to fill the rest up with water. And again, you want to make sure not to go over the line. Okay, and so that is how you would make the solution. So again, just reviewing our equations that we did, on our first problem, it was pretty straightforward. We were given moles, we were given 500 milliliters, so we need to plug it into our equation. The only thing that we need to do is make sure that our milliliters were converted into liters. So we had 0.5 liters because, again, there are 1,000 milliliters in 1 liter. Then what we have here is we have our, we had another example, and we were given 25.5 grams of sodium chloride, 250 milliliter solution. And so what we had to do is, in order to find the concentration, we had to convert our grams of sodium chloride into moles of sodium chloride. And we did that using our molar mass. And once we had that, then we could plug it into our molarity equation where we had the moles of our solute over the liters of solution. And then our last one was asking how you would make a solution. So again, if we wanted to make a 0.125 molar solution of KCl, the first thing that we needed to figure out, or the math part, is what is the mass of potassium chloride that we would need? So I need to figure out how many moles of potassium chloride using my molarity equation, and then convert those moles into grams. And once I figured out how many grams of potassium chloride I needed to put in the solution, I could write out a couple steps. So again, weigh out the 3.26 grams of potassium chloride, add all that potassium chloride to a 350 milliliter volumetric flask. Then what you want to do is add approximately 200 milliliters of water and dissolve the KCl. Now again, maybe you put 150, maybe you took your 350 and actually divided it in half. The idea is that you add an amount of water or enough water to dissolve it, making sure that it's not all of it. And then you fill the rest up with water, making sure not to go over the line on the volumetric flask. And so those are 3 types of problems that you will see with molarity.